Okay, so we are going to do our interest word problems, and I've already pre-worked these out, and so you might want to have that pause button ready so you can stop and take time and program this in your calculator and see what to do, and make sure you get the same values that I do. Alright, so the first thing you want to do is read the problem, and here's the first example. Morgan Presley invested a bonus of $9,000 at 6% annual interest compounded semi-annually for 4 years. How much interest will she earn? Okay, so first thing you have to do is decide which formula that you need to use. That I gave you the two on the handout. So I'm going to look at the wording, and you're going to look and see how the interest is compounded. So anything like compounded annually, semi-annually, monthly, quarterly, anything like that, that's going to be that formula, that the first one that I gave you. And so, sorry, I'm doing a voiceover and I'm waiting for it to catch up with my writing. So hold on, it'll catch up in a second. Sorry, the first time I did this, there it goes. So compounded semi-annually. So that tells me to use that formula where it is A equals 1 plus R over M raised to the T times M. So what I like to do is list out those variables, A equals, P equals, R equals, M equals, and T equals, and then I take the numbers in the problem and I'm going to fill them in. So, alright, Morgan Presley invests a bonus of $9,000. So that $9,000, how much she invests, that's the principal, so that's P. Alright, at 6% annual interest rate. Remember, you want to change that 6% to a decimal, so 0.06, move it 2 places to the left. Compounded semi-annually, that's how many times you compounded a year, so semi-annually is twice a year, and time, 4 years. So remember, times in years. Alright, now all we're going to do is fill in the variables, fill in all the numbers, and we're going to plug this into our calculator. Again, just make sure you have that pause button ready. So the first thing you want to do is do the inside of that parenthesis. So you want to do the 0.06 divided by 2 and then add the 1, and when I did that I got 1.03, and then you raised it to the 8th power, because that's 4 times 2, not 4.2. Alright, so then I raised that to the 8th power, and so it's 9,000 times, I didn't actually keep them separate. I raised it to the 8th power and then multiplied it by 9,000. I got 11,493. Now, make sure that you answer the question. That's the tricky part. So go back and look at what the question says, and it says, how much interest will she earn? So that's what it's asking for. How much interest will it earn? So that's not the answer. What you found, A, is not the answer. Okay? A, I want you to remember, A always stands for the amount in the count. That's how much you end up with. That's not the interest that you earn. So to find the interest, okay, that interest is going to be equal to, you'll go over to the side and you'll do this quick formula. That interest is equal to A minus P, the amount in the account minus the principal, what you invested, and that's how much interest that you earn. So you're going to take that 11,493 minus that 9,000, and the interest that we earned was $2,400.93. Okay, so always pay attention to what the question asks. If it asks how much, interest, you have to do that second little formula. If it just says how much do you have now, then you get to go with that A answer. So be careful on those. Alright, so we will move on to our second example. Okay, so let's read it. Suppose that you plan to need $10,000 in 36 months' time when your child starts attending college. You want to invest in an account yielding 3.5% interest compounded monthly. How much should you invest? So again, the first thing we're going to do is look for that compounded monthly, so we see what formula to use. We're using the same one, A equals P times 1 plus R over M raised to the T times M. List out all those variables so we can fill them in with the numbers from our problem. Alright, so suppose that you plan to need $10,000. So $10,000 is how much I'm going to end up needing, not what I start with. So that's how much I'm going to end up with in the account. So that $10,000 becomes A. Okay. All right. And then the next thing I see is 36 months time. Remember, time is in years, so you need to convert that to years. So 36 months, okay, would be 3 years. All right. I want to invest in an account earning 3.5% interest, so change that to a decimal, 0.035. Again, move it 2 places to the left. And how much should I invest? I'm looking for P. Oh, and it says, compounded monthly. So again, how many times would that be over the year? It would be monthly, would be 12 times a year. All right, and then I'm looking for how much should I invest. So what do I need to start with? So let's fill in all those values. So 10,000 would be equal to P times 1 plus 0.035 divided by 12 raised to the 3 times 12. All right, now remember, do the inside of the parentheses first. So when you do that, you're going to do 0.035 divided by 12 and then add 1 to it. And I got, when I did that, 1.0029167, and 12 times 3 would be 36. I kept a whole bunch of decimal places out, and I'm around to 2 at the end. All right, so then I took that 1.0029167 and raised it to the 36th power, and I got 1.11054. And then to solve for P, I would just divide both sides by that 1.11054. So I got that how much I need to invest is $9,004.62. So no way you can do these without a well, you can, but no way you want to do these without a calculator, so make sure you have one that'll do this. All right, third example. If $600 is invested in an account earning 2.75% compounded continuously, how much would be in the account after 5 years? All right, so compounded continuously, that's that second formula that I gave you, A equals P times E raised to the RT. So list out the variables. A equals P equals E is not a variable in this. R equals T equals. All right, so let's start and figure out what these numbers are. All right, if $600 is invested, okay, so $600 is how much I start with. So 600 becomes my P. Okay. And an account earning 2.75%, so change that. 0.0275 becomes my R. Right. How much would be in the account after 5 years? So there's my time. Alright, so A equals 600 times, and I'm just putting those in parentheses so you don't mix them up. So E raised to the 0.0275 times 5. So first thing you want to do is find that E button on your calculator, okay, and you're going to, you want to do the 0.0275 times 5, and you get 0.1375. Alright, so now you want to find your E button on your calculator and do E raised to the 0.1375. So look for that button and make sure you get 1.147402, something along that. And again, I keep out a whole bunch of decimal places and I rounded at the end, and then I multiply those together. So I got that A equals $688.44. Now again, you think about, did you answer the question? Well, it said how much would be in the account. So it's asking for the amount in the account, so we get to stop right there with that A, and it didn't ask me how much interest did I earn or anything like that, so there's no subtracting. So that is my answer. Alright, 2 more. Okay, number 4. Susan has received a bonus of $25,000. She invested in an account earning 7.2% compounded quarterly. Find how long it will take for her $25,000 investment to grow to $40,000. So compounded quarterly means I go back to that same formula, and A equals P times 1 plus R over M raised to the T times M. So list out the variables. Here we go. I received a bonus, or Susan did, $25,000, and I invest that. So that becomes my principal. That's how much I'm investing. So $25,000 is my P. All right, and an account earning 7.2%, so change that, 0.072. Compounded quarterly. Quarterly would be 4 times a year. How long will it take for $25,000 to grow to $40,000? So I don't know. I'm looking for the time, and I know that I'm going to end up with $40,000. So the amount in the account is going to be $40,000. Okay. We haven't had one like this where we solve for the T, so let's make sure we remember how to do that. So fill it all in. 40,000 equals 25,000 times 1 plus 0.072 divided by 4 raised to the T times 4, and I just went ahead and wrote it as 14. Alright, so simplify that. First thing I'm going to do is get rid of that 25,000 on the front. So divide both sides by that 25,000 to get rid of it. Alright, so divide that, and you end up with 1.6. Alright, and then put that together, 0.072 divided by 4, and then add the 1. Alright, so remember, do that division first and then add the 1. You should get 1.018 raised to the 4t. Now, think back to your college algebra. You got to solve for a variable that is in the exponent. Okay. So again, I've just shown y'all that I was dividing by that 25,000. That's how I got that 1.6. All right, so you got to solve for t, and t is in the exponent, so you got to get it down to the ground. So think back to college algebra and the way that you solved for that exponent that was in the air. The way you solved for that variable that was in the exponent is you had to take the natural log of both sides. That's how we get it down to the ground. So you're going to take the natural log of 1.6 equals the natural log of 1.018 raised to the 4t. The property of logs means that you got to take that 4t, that exponent, and drop it down in front of the log so you can bring it down to the ground just like I did right there. Okay, now I went ahead and plugged in natural log of 1.6 into my calculator and the natural log of 1.018. So make sure you find that natural log button on your calculator. So when you do the natural log of 1.6, I got 0.470036. And I did the same thing, 4t times, and I did natural log of 1.018, and I got 0.01784. Alright, now you have two options here. You can go ahead and multiply on that right side the 4 times the 0.01784, and then just divide by whatever that is to get the t by itself. I divided it in 2 separate steps, and either way you do it, the same answer. So the first thing I did was divide by that 0.01784, both sides, and you end up with 26.3455. So I had to move it up. I was running out of room, so I moved it up here. So 26.3455 equals 4t, and then you could divide by the 4, and you can get your answer 6.58. So again, you can do it that way, or I could have, right back before I moved that over to the right side, you could have multiplied the 4 times the 0.01784 and just did 1 divided at the end. Okay, so how long? You've got 6.58 years, but remember, you're compounding this quarterly. And one thing you have to remember is that interest is added at the end of the quarter. So what you want to do is take that 6.58 and round it up to the next quarter. So when you do that, it would be 6.75 years. So again, interest is added at the end of the quarter, so you have to just round that up to get your actual time. Okay. All right, one more to go. So we'll do this last example. Alright, Tom has a balloon payment of $100,000 due in 5 years. What is the present value of that amount if the money earns interest at 4.5% annually? Alright, so I see that annually. I'm going to go to that formula equals P times 1 plus R over M raised to the T times M. Fill in my variables. Alright. One thing to remember is when you see what is present value, and you'll have several on your quiz and your math lab to ask you about that, present value is always asking for P. Okay, so I know that's what I'm going to solve for when it says what is the present value. Alright, so that balloon payment of $100,000 is going to be my A. I'm looking for P, okay, because that's how much money I'm going to get in 5 years, so now that's how much I'm going to end up with. My rate is 0.045 annually, means M is 1, and it was 5 years. So fill that in, and so 100,000 equals P times 1 plus 0.045 divided by 1 raised to the 1 times 5. And then you just want to solve it from here. So if you did the inside of that parentheses, you would do 0.045 divided by 1 would be 0.045 plus 1, 1.045. Right, and then raised to the 5, and you could plug that into your calculator. 1.045 raised to the 5, I got 1.24618, and then divide both sides by that 1.24618, and you get that present value P is $80,245.10. Alright, so I hope these examples helped.